In chemistry, we make several different measurements, and we need to know what the quality of these measurements are. To demonstrate the quality, we use significant figures, or sig figs for short. In this video, I will go over how to determine the number of sig figs in a measurement, and how to use them in calculation. Give a quick example. Imagine that you are measuring a beaker of water on a balance. This balance tells you it has 131.10 grams. We know the certainty of this measurement to the hundredths place in this case. Sig figs helps us show that we know it to the hundredths place. So let's go through the rules on how to determine a sig fig. First, anything other than 0, meaning any number between 1 and 9, is significant. So, if we have the number 19, both 1 and 9 are significant. Now, a word of caution here. We are just looking at the numbers that we are given in each example because each one is a measurement. Also, don't assume that there's a decimal or extended zeros in after this. We are, again, just looking at the number. So, we are going to count the number of significant figures. We have 1, 2. So this example would have 2 sig figs. 0 has several different circumstances. Rule 2 says any 0 between digits other than 0 are significant. Meaning, for example, if we had the number 7,009. Both 7 and 9, according to Rule 1, are significant. Well, we have 2 zeros sandwiched between a number other than 0, so those also count as significant figures. So for this example, it would have 4 sig figs. Rule 3 says that any 0 after the decimal are significant. So if we have a number such as 0.780, 7 and 8 here are both significant. This 0 on the very end is also significant because it follows the decimal, and the other part of this is that it follows a non-zero number, meaning that it follows a number 1 through 9. We're not worried about this number up front. We'll talk about that next. So this number, 0.780, has 3 sig figs. Rule 4 says that zeros before the decimal or at the end of a very large number are not significant. So let's look at two different numbers. Let's look at 0.034 and 780. So in this case, according to Rule 1, 3 and 4 are both significant. These decimals here at the front, we are not going to count. They are what we call placeholders. The only time that a 0 after a decimal will count is if it follows a non-zero number. So 0.034 only has 2 sig figs. Similar case with 780. 7 and 8, according to Rule 1, are significant. However, this last 0 on the end, again, is a placeholder. So this would only have 2 sig figs. Now, the only way that this can change is if there is a decimal. If the decimal is present, that means everything in front of that decimal is significant. So 780 would go from having 2 sig figs to 3 sig figs. That's the only chance. Now, Rule 5 applies for when we're doing calculations. If we have a number such as pi, it would have infinite sig figs. Because when we're doing calculations, there's a few rules that we'll talk about, and we don't want certain numbers such as pi and other constants to mess up with the numbers. Alright, let's do a few examples. First here, 8,009.5. 8, 9, and 5 are all significant according to Rule 1. The 2 zeros here in between 8 and 9 are also significant according to Rule 2. So this number has 5 sig figs. Now I'm going to continue working these examples, but you may choose to pause the video and work them on your own first, and then come back to the video and see how you did. Example 2. 5 and 6 both are significant, according to Rule 1. 0 follows a 1 through 9 number, so it is also significant, according to Rule 3. And the first two zeros here, 0.0, are placeholders, according to Rule 4. They do not follow a 1 through 9 number. So this number has 3 sig figs. The third example. We have 5, which according to Rule 1 is significant. According to Rule 4, these last two zeros, are not significant, so this only has 1 sig fig. And finally, 6.08. 6 and 8 are both significant according to Rule 1, and similar to the first example, 0 sandwiched between them is also significant according to Rule 2. So that means this has 3 sig figs. Now let's talk about how to calculate stuff. When we calculate stuff, we have two sets of rules. One applies to addition and subtraction, the other applies to division and multiplication. Start with addition and subtraction. With addition and subtraction, we're looking at the last common placement furthest to the right. When I mean placement, I'm talking about ones, tens, hundreds, tenths, thousands, things like that. The best way with addition and subtraction is to write the numbers vertically. So we have the ones in common here, and we have the tenths in common here. But only the bottom number has a hundredths in common. So the last common placement between them, furthest to the right, is the tenths. So let's go ahead and calculate our answer. 9.88 is the correct answer. Now, we're going to round to the last common placement. So the actual answer for this is 9.9. So to consider the sig figs, you always round to wherever the rule tells you to. So with addition and subtraction, you find the last common placement furthest to the right, and that's where you round. Multiplication and division is slightly different. We're looking at the least number of sig figs between any numbers. So 789.05 has 5 sig figs. 5.7 has 2 sig figs. So when we actually calculate this number out, we will round to 2 sig figs. So this actually answer is 138.43. We're going to count from left to right 2 sig figs. So that means we're going to round to the tens place. So this number would round to 140. Remember, there's no decimal there, so that last zero doesn't count. Let's do some practice problems. Alright, to start with, addition. I'm going to write this vertically. Now, we're going to look for the last common placement after the decimal. Furthest to the right. This most often is after the decimal. So all the ones are in common, all the tenths are in common. The second one doesn't have hundreds, so that means our last common placement is going to be the tenths. Okay, if we do our answer, we get 4.953. We're going to round to the tenths place, so the final answer would be 5 grams. Now, I'm going to continue with using to calculate the last 3 problems, but you may continue on your own as before and pause the video and then come back and see how you did. Alright, let's start with subtraction. I'm going to write it vertically again because it just makes it easier. Go ahead and do our subtraction. In this case, the hundredths is the last common placement farthest to the right, so that means we will round to the hundredths, so our answer will become 7.45 meters. Alright, moving on to addition, division and multiplication. We are going to look at the number of sig figs. So 923 has 3 sig figs, 20,312 has 5 sig figs. So we're going to round to 3 sig figs. So this answer is equal to 0.04544 grams per centimeter cubed. These first two numbers are not significant, so let's start counting here. 1, 2, 3. So we're going to round to this number. So our final answer is 0.0454 grams per centimeter cubed. Likewise, with multiplication, we have 3 sig figs for 123,000, and we have 4 sig figs for 3234. So we go ahead and we multiply out our number, which is 39,778,200 meters squared. So if we want 3 sig figs, we count 1, 2, 3. So we're going to round to displacement. So that will equal 39,800,000 meters squared. This concludes this video. Thank you for watching.